Okay, question 8a, complete the table 8.1 by placing one tick in each row to indicate the sign of each type of energy change under standard conditions. So here is table 8.1. Now we need to take, this is energy change. The first one is lattice energy. You know, guys, lattice energy is produced by the combination of two gaseous ions to form ionic solids. So actually this is always negative. It must be always negative. Second one, enthalpy change of hydration. You know, guys, hydration, same idea. Also, this is combination with water molecules. So combination will be also always negative. Third one, enthalpy change of solution. You know, guys, for solution, we have endothermic solution, we have exothermic solution. It depends regarding to the value of energy in and the value of energy out. So actually, it can be either negative or positive. This is for solution. Okay. Letter B, define enthalpy change of hydration. So we could say this is enthalpy change when 1 mole of gaseous ions dissolves in water to form very dilute solution. Okay, letter C, table 8.2 shows various energy changes which can be used in the following question. So this is table 8.2. Here we have the values of some energies as we see. And then the question is, select and use relevant data from table 8.2 to calculate the lattice energy of calcium bromide. This is calcium bromide, guys. Okay. It may be helpful to draw a label energy cycle to your work. Actually, guys, to calculate the lattice energy for calcium bromide, actually we need to remember basic processes we need to do. Actually, we need to start by this. If you check the elements in their standard states, and this is really important to know about the starting point. This is the starting point, guys, here. So here we have, this is, as you see, calcium, which is solid. This is its standard state. This is calcium solid plus Br2 liquid, as you see. And then we can move up, if we go up like this, and we can also move down. So what is the difference between them? Of course, if we move out, this is positive, a change endothermic, and if we move down, this is negative, change, which is exothermic. Okay, if we move down, actually, guys, this is called a standard enthalpy change of formation, and this is to form calcium bromide. Look at this. This is calcium bromide. So if we consider this stage is 1, or the beginning, so this is the final, beginning and final, directly. So actually this is one route. Standard enthalpy change formation is one route from elements in their standard conditions into the final compound. This is solid ionic compound. So we can do this by a process called standard enthalpy change of formation. However, we can reach the same destination, but by a number of processes. So let's check this other route. Remember the route from calcium plus bromine to this is direct route. This is one step only. This is direct route. And then if we go up like this, so we have a number of steps or processes, which is indirect routes. First of all, you know, guys, calcium should undergo, because it's solid, atomization. So in order to be gas, so this is the first enthalpy change. And then calcium, from being gas, we need to make first ionization energy in order to remove one electron. So this is plus one electron. Okay. And then we need also another ionization energy, or second ionization energy, to form Ca2 plus. Actually, bromine here, this is liquid. So we need to change into gases. So this is also atomization. So standard enthalpy change of atomization here, but remember this is BR2, so we should say times 2. Remember, enthalpy change of atomization should be multiplied by 2. And then we're gonna have 2 PR gas. Then we need also to change this atom to be ion. So the next process is electron affinity. So electron affinity AA1, this is first electron affinity. And remember, because we have 2 atoms, so we need also to multiply 2. And then after electron affinity, after gaining electrons, and because this is gaining electrons, so the enthalpy change is going to be exothermic. So the arrow moves down as you see. So this is 2 times PR negative gas. So if we need to calculate this, actually, we need just to state that standard enthalpy change of formation regarding to this equals, remember this guys, this is the one route, direct route from the elements to that compound directly. It equals sum of all of these processes. So we need to say sum of, this is standard enthalpy change of atomization. This is for calcium, plus also we have ionization energy 1 for calcium as well, plus ionization energy 2 or second for calcium. And then we need to add also, here we have atomization for bromine, but remember this should be times 2, so 2 times standard enthalpy change of atomization, and this is for PR, and plus also electron affinity, plus here we have 2 times electron affinity 1 for bromine. Okay, we need the last step to add also lattice energy here. So this is plus standard enthalpy change of lattice energy. Actually, we need to calculate lattice energy. So let's make it the subject. So I'll make lattice energy the subject. So standard enthalpy change of lattice energy equals, I'll take all of these values to be minus on the other side. So it's going to be delta H formation minus, and then we can put all of this. So delta H atomization for calcium, and then ionization energy 1 for calcium, plus ionization energy 2 for calcium, plus 2 times enthalpy change of atomization for bromine, and finally plus 2 times electron affinity 1 for bromine. Okay, I think now we can substitute directly through this, and then we can take the values of the table. Okay, so standard enthalpy change of formation regarding to the values given in the table will be, so let's take formation. Let's come back to the table. So if standard enthalpy change of formation will be this one. So negative 682 point. Okay, we can do it here quickly. Better to be clear. So this is negative 682.8. This is formation. Then minus, open brackets, and then let's start by atomization of calcium. So atomization for calcium, this is the first one up. So this is 178.2, 178.2, plus ionization energy firstly for calcium, it's going to be here. Okay, guys, all values are in the table. So this is 590, 590, plus second ionization energy for calcium. So this is also here, 1145. So this is 1145. So this is everything for calcium, as you see, is done. Let's also add bromine. So atomization for bromine. So here we have, this is atomization for bromine. And take care, we need to say times 2. So this is plus 2 times, this is 1.9. And finally, also electron affinity. So electron affinity, first electron affinity here, guys, of bromine, look at the value. So take care because this is minus. So we can say plus minus or minus directly. And remember, this is 2 also times this value, 3 to 4.6. Okay? So actually everything here equals standard enthalpy change of lattice energy. So we can do this process, and then let's see, I'll do it quickly in the calculator. So let's see actually what is the value for this. Okay, you can do it also. So the final or the total here is going to be negative 2170.6 kilojoule mole negative 1. Okay, guys, so this is the value of the lattice energy. Okay, next question, double I. So here we can add the final, which is again negative 2170.6. But actually, guys, it's very recommended to show your work here in this space. Everything I did on that blank page here, so you can only copy everything. Okay, double I, select and use relevant data from table 8.2 and your answer to CI to calculate the standard enthalpy change of hydration of bromide ion. It may be helpful to draw a labeled energy cycle. If you were not able to answer CI, use negative 2500 kilojoule mole negative 1 as your value for standard enthalpy change of lattice energy of calcium bromide. This is not the correct value. So show your work. So actually we can use our value here, actually, guys, as you see, for the lattice energy. So let's check. This is that enthalpy cycle generally. So here you have, if we have gaseous ions, so we have also two routes. Direct route, which is hydration, and standard enthalpy change of hydration to combine with water to form aqueous ions or ions in aqueous state. And here we have another route, which is indirect route. So indirect route, so by these ions will combine in through lattice energy to form ionic solid. And then we have another indirect route. So we can dissolve this ionic solid in water to produce also ions in aqueous state. So what does it mean? It means that enthalpy change of hydration equals, which is the direct route, equals the value of lattice energy plus the value of standard enthalpy change of solution. Okay, and since we have also hydration will be for two ions, so we can also convert this into standard enthalpy change of hydration for calcium plus standard enthalpy change for hydration for bromide ion. And we need to remember, guys, actually this is times 2 also because we have Br2. So this is calcium, okay, and here this is of course gas, and this is gas also. Both of them equals sum of lattice energy plus standard enthalpy change of solution. Okay, and then we can substitute the values as given. For lattice energy, I think this is the one we calculated together. It's negative, let's check, it's negative here 2170.6 to 107.6 plus standard enthalpy change of solution. This is mentioned in the table. So this is enthalpy change of solution. Yeah, it's here. So actually it's negative 103.1. So negative 103.1. And there also we can substitute the value of hydration of calcium. So standard enthalpy of hydration of calcium, this is here. So it's negative 1579, negative 1579. plus 2 times enthalpy change of hydration of Br minus. So I think now, guys, it's very clear. We can make bromide ion as a subject here alone. So this is 2 enthalpy change of hydration of bromide ion equals these values, 2107.6. This is plus minus, so it's going to be minus 103.1. And here we can take all of these to the other side to be plus. So plus 1579. And then let's do it in the calculator. Let's see the final. So it's going to be 694.7 negative. And this is, remember guys, this is 2. So if we want the final, because this is only, we need to cancel this 2, so time divided to everything. So delta H hydration of bromide must be this value divided to 694.7 divided 2, so it's going to be 347. This is kilojoule mole negative 1. And also remember, this is negative. It must be negative also here because this is negative, and enthalpy change of hydration is negative as well. Okay, so we can copy this negative 347, and also you should show your work. So this is negative 347 kilojoule mole negative 1. Okay, triple I, the enthalpy change of hydration of the Br negative ion is more negative than the enthalpy change of hydration of the iodide ion. Explain why. Actually, guys, you know, both of them are in the same group in the periodic table, but Br, actually, it's above I. This is group 7 or 17 of halogens. So if we talk about ions, so actually the one above has a smaller radius or ionic size, and the one down has bigger ionic size. Okay, so first of all, we need to say that this is because Br minus has a smaller radius, or you could say ionic size. And as you know, guys, the smaller the ionic size, the more attraction with water molecules. So it forms a stronger attraction with water molecules. Hopefully it was helpful. Thank you so much, guys. See you.